Okay, welcome everybody. Good evening to you all. Good evening to all our members, and a special welcome to our many guests for this evening. A very special webinar for the Society for the History of Astronomy. For those of you who don't know me, I am the chairperson for the Society, and as John's mentioned, I will be introducing our very special guest this evening. Before I begin, I'd just like to mention that if you can also turn off your videos, that does help with the internet connection. And please make sure that you are muted, because in the past we've heard people doing the washing up, and we don't want to interrupt things this evening. We will obviously be having questions and answers at the end, with the kind permission of Brother Guy. But there is also the facility of the chat. So during the presentation, if you do come up with a question, please type it there and we'll try and get to you at the end. Our plan is to have a presentation for about 45 minutes or so, and that will be followed by questions and answers. So without further ado, I would like to introduce our speaker for this evening, and it is a great honor for me as your chairperson to introduce Brother Guy, who is a Jesuit brother, director of the Vatican Observatory and president of the Vatican Observatory Foundation, whose research studies include those of meteorites and asteroids. He is a native of Detroit, Michigan, and received an SB and an SM degrees from MIT, and earned his PhD in planetary sciences from the University of Arizona in 1978. Along with more than 200 scientific publications, he is the author of 6 popular astronomy books. And in 2014, he received the Carl Sagan Medal from the American Astronomical Society Division for Planetary Sciences for excellence in public communication in planetary sciences. His talk and webinar this evening is entitled, "Why Does the Pope Have an Observatory?" And the abstract reads, "The roots of the Vatican Observatory go back to the Gregorian reform of the calendar in 1582, and it has been part of an extensive history of church support for astronomy, in brackets, Galileo to the contrary, close brackets. Its modern mission for the last 100 years has been to show there is no inherent conflict between science and religion by simply being people supported by the church whose sole mission is to do good science. But the observatory's origins are also closely tied to the 19th century political conflicts between the anti-clerical Italian government and the Holy See. A national observatory and a strong reputation in the burgeoning field of science were seen by the Vatican as an important tools for statecraft. The development of this relationship between astronomy, church, and politics has continued to develop since then, most notably during the papacies of Pope Pius XII and the late John Paul II. So without further ado, may I introduce Brother Guy. Thank you very much. If you will mute yourself.
There I go. Yes. All right. Now you can hear me. Great. I'm delighted to be here. I'm hoping that the screen is showing my first slide. All right. Why does the Pope have an observatory? Well, I've got so many different screens open that I have to be sure. Yes, okay, this is the one I want. It really goes back to 1582 and the reform of the calendar. I'm assuming for a group like this, you know most of the story of the reform of the calendar, why it needed to be reformed, and the less than exact match between the number of days in a year and the length of a year, so that it's 365 and a quarter, but not quite a quarter. Every century or so, they needed to get rid of a day. There was also in the 1500s the issue of determining the date of Easter in a way that could be worked out and applied all around the world. It's one thing to say that it's the first Sunday after Passover. What happens if Passover is on a Sunday? Well, it's the next Sunday. What happens if Passover is on a Sunday in one part of the world, but it's a Saturday in a different part of the world? And then things get very complicated. Father Christopher Clavius, who was a Jesuit priest and a mathematician, was one of the people who helped reform the calendar, and in particular, described why the reform was made and how it was made. Incidentally, the answer for the date of Easter, it's an arbitrary formula. It's no longer exactly tied to the position of the moon. And we saw an example of that this year, because it was new moon, it was full moon on a Saturday in some parts of the world and a Sunday in other parts of the world, but we had Easter on that day anyway. One of the things that happened with the reform of the calendar was that a tower was built in the Vatican itself on near St. Peter's to demonstrate the need for the calendar reform. It's not so much that they made this as an observatory, but this was, if nothing else, a PR stunt. In that tower is a room painted with various murals of the winds, called the Tower of the Winds. And let's see if I can. When you have a beam of light coming through one wall, as the seasons move, the spot on the floor where that beam of light hits at noon will shift to the far wall when the sun is low in the wintertime, and close to the wall, the other wall in the summertime. It turns out the hole is such that the light doesn't actually get through from about the end of May to about the end of June. But don't tell anybody that's the case, because it's much too glorious a story. This room was built mostly to show visiting guests that a reform of the calendar was needed. Clavius's trick of having a formula to come up with Easter meant that he could then work out the formula, and he published a book in 1603 that, this is Christopher Clavius, that actually calculates the date of Easter and all of the other moving feasts up to the year 5000. This is a copy from our library, and you can see here the actual dates of Septuagesima and up to the Ascension, highlighting the years 2022 and 2023. And of course, they're right, because they follow the formula. If you look carefully, and I forget exactly where it is, there is a typo on this page. And so he's got the month of Easter wrong one year, but don't tell anybody about that either. Clavius was notable for a number of reasons. He, among other things, he wrote a letter in support of Galileo, when Galileo was looking for a job as a young man. And Galileo, of course, has this famous dispute with the church. I don't want to turn this into a Galileo talk, because that would be a whole, another hour, and you've probably had people better than me talk about Galileo. But I want to bring up one particular point of conflict between Galileo and the Jesuits after Clavius and the other Jesuits had endorsed the telescope in 1612. They had a falling out, among other things, as to who was the first person to see a comet, or first person to see sunspots. Galileo insisted he was the first. Christopher Scheiner, the Jesuit, insisted he was the first. And of course, I'm sure everybody in this room knows it was really an Englishman, Thomas Harriot, who saw them before either of those two guys. What happened in 1618 is kind of interesting, because, as you know, comets are not all that common. There were 3 naked eye comets in the year 1618. And Orazio Grassi who was a Jesuit who was fascinated by astronomy, observed one of the comets, actually observed all of them, but one in particular, a particularly bright one, with a telescope. And his other Jesuit friends of his in Germany observed it at the same time, on the same date, saw that it was exactly the same place in the sky from both positions. There was no parallax. And that indicated to them that the comet was out beyond the moon and still moving in an orbit that neither the Copernican nor the Tycho Brahe system nor any other system could handle, because of course it was an elliptical orbit and you needed Kepler, and nobody was really paying attention to Kepler at that point. But certainly it was not moving in a circular orbit. He writes an article about this saying, anyone who understands a telescope will appreciate this. Galileo was sick in bed and never saw the comet. So Galileo writes an article against it, signing somebody else's name to it. Grassi writes an article against what Galileo wrote. They're basically arguing past each other. And Grassi, being the more professional scholar, is writing in elegant Latin and quoting the ancients, as one did then. Galileo basically was a college dropout because he was flunking Latin. And so he writes in Italian. And he says, don't listen to what the ancients said. They don't know anything. You've got to pay attention to what you actually see. Pay attention to the data itself. This comes out in a book called the Observatory. The Grassi's book had been, about balancing one with the other. And Galileo's Observatory is the fellow who's balancing things in a watchmaker's balance or a jeweler's balance, a much finer balance. And along with saying that you have to pay attention to the data, he also pontificates about the comet that he never actually saw by saying, of course it can't be, it just must be something in the sky. It's not real in the atmosphere. It's not really something out in space, because if it were, then all my theories would be wrong. And he didn't want to admit that. So Galileo both promotes the first idea of how science ought to be done that we all follow, and was the first to actually violate that. But so what else is new? In fact, the scientific evidence in favor of the Copernican system in the 1600s was very, very weak. And again, that's a whole long story. If you want to know more about that, I highly recommend a book by a fellow named Christopher Graney, writing about not Galileo, but a Jesuit who came after him, Giovanni Battista Riccioli. And this is a copy of Graney's book, and then also a copy of the predecessor of Riccioli's book itself. The interesting thing about this particular book that's holding on to this day is Riccioli was the first to come up with an accurate map of the moon that uses the nomenclature we use to this day. So he talks about the, Oceanus Procellarum. He talks about the crater Copernicus, Mare Vaporum, all the things you can see in the picture here. The craters circled in red, Riccioli starts the idea of naming craters for prominent astronomers. And the astronomers circled in red all happened to be people who believed in the heliocentric system. Even as he argues against the heliocentric system in the book, he's arguing against it not on religious basis, but on the best science of the day. They didn't understand how telescopes work. They didn't understand, if the Earth is moving, why can't you see parallax? A number of arguments, which are good arguments, but turn out to be wrong, of course. The interesting thing that is right next to Copernicus and Kepler and Galileo is crater Ricciolus, which is the crater named for himself, and Grimaldus, who was a student of his. So it shows that he was not afraid to be associated with that point of view. The idea of using big dark rooms as giant observatories was really taken hold of by Cassini. And one of the first was in 1655, he went to the cathedral in Bologna. You can go there to this day. And in the south wall, there's a tiny hole. The sun goes through the hole. It's like a giant pinhole camera. And you can not only trace where it crosses the meridian line, and from this eventually measure out the exact latitude and the exact time in any given day. And from these details, eventually you can work out the latitude and longitude of where that cathedral is. But also, they were trying to see if you could see a change in the size of the sun itself. The measurement to see if this was more like the Keplerian system, or if it was more like a Tycho Brahe or a Copernican. Were things in circles, with circles within circles, or was it more shaped like Kepler had come up with? The trouble is that that detail of measurement requires you to be able to measure to a precision that is impossible because of the wave nature of light, which was also the thing that screwed up the observations of, well, suns look like little spots in my telescope. If that's actually the disk of the sun, then they must be close by. And if they're close by, then we should be seeing parallax, and therefore the Earth can't be moving. Again, it was the wave nature of light. And incidentally, the guy who first talked about the wave nature of light was that Grimaldi, who I pointed out had the crater named for him earlier on. Cassini eventually went to France and did this trick with cathedrals all throughout France, came up with the first really accurate map of France, which showed that France was about 10% smaller than the old maps had said. And the king of France at that time, was one of the Louis, said, "Oh, thanks to your map, I've lost more territory than I've lost in all my wars," which also tells you how good a warrior that particular king of France was. Another Jesuit and astronomer notable at this time was Roger Boscovich. And most people who know Boscovich know him as the fellow who came up with the atomic theory in a book about the atomic theory in 1758. But in fact, he was one of the first to push teaching experimental physics in the Jesuit schools. He observed the transit of Mercury in 1736. He encouraged people to get ready for the transit of Venus, even though he didn't live, well, he did live to see it, but he was, for reasons having to do with the politics of the day, he wasn't able to. And he was the guy who managed to convince the church to lift the prohibition of teaching heliocentrism as a philosophy. Up to this point, you could learn the Copernican system in the Jesuit schools as a mathematical system. Here was the point where finally, by the middle of the 18th century, which is where we are now, they understood better how the Copernican system could work, with the Keplerian version of the Copernican system. Newton's version of Newton's laws and Newton's law of gravity finally gave substance to that theory, which wasn't there in the early 1600s. The irony, of course, is that while the church accepted the Copernican system, they kept the books of Galileo on the list of these are dangerous, general people shouldn't read them, for another 50 years. But this is Italy, nobody pays attention to the rules. Just to indicate that, in fact, yes, the idea of stars and many stars having many planets was commonly accepted. This is a painting in the ceiling of the Jesuit college, what's called the mathematics room, dating from 1760. This is in Prague. This ceiling is still there. You can go and see it. You've got all of these little angels looking through telescopes, and there are stars circled by planets and comets. This is 1760. One last thing to give, sort of the counterexample. I'd mentioned before the talk came that we've got here at the Vatican Observatory a complete set of the philosophical transactions. I have to confess, what happened was when we moved out here to Castel Gandolfo, the Vatican Library saw this as a chance to free up some shelf space, and they dumped on us all of their modern science books. And to them, anything printed with a printing press is modern. So we've got, a copy of Copernicus, we've got copies of Newton. At one time, I happened to pull at random This was not cherry picking. I don't know if this is true of all of them. I haven't looked too many of them, but this is fairly typical. The table of contents from, I think it's what, 1632, and just see who is writing. We've got a medical doctor who writes a paper, a nobleman, a German who's a fellow of the Royal Society, a sea captain, a reverend who's also a lawyer, and another nobleman. Who's doing science in the 16th century, in the 17th century, in the 18th century? The only people who are doing science are the people who can afford to do it. They have to be wealthy, or they have to have a steady job that, steady income, like a clergyman. They have to be educated, which again means either a nobleman or a clergyman. And they have to have the interest in the skills in doing it. If you are a member of a religion that said God created the universe and God is logical, because it's what Thomas Aquinas was saying, then you've got the philosophical cover to spend your time studying this physical universe. Plus, think on this. What does a scientist actually do day to day, over and over and over again? You keep records. And after you've kept enough records, then maybe you're going to, when I was a kid, you'd write things on 3x5 cards and sort and file them. Now we've got Excel spreadsheets, but it's still sorting and filing data. If you're, a parish priest, what are you doing? Keeping tracks of records of births and baptisms and marriages and deaths. It's data keeping. What do we call that job of data keeping? We call it clerical work. Why do we call it clerical work? Because it was done by clerics. And so you find it's very common, well into the early 19th century, that most of the people actually collecting data tend to be clergymen. They're the ones spread out, especially the missionaries. They're the ones who are going to the other interesting parts of the world and seeing plants and animals that nobody had seen before, and writing them up because they're all educated. They know how to write and read, and sending it back to headquarters in Rome or wherever their missionary headquarters might be. It's the clergy who are doing the actual day-to-day work of the science. And I'm now going to spend some time talking about one particular clergyman, because he is key to the foundation of the Vatican Observatory. And he's probably the greatest astronomer you've never heard of. His name is Angelo Secchi. He was remarkable as a scientist. He built the first electromechanical gizmo that would automatically record weather so that you didn't have to have somebody looking at a thermometer every hour and writing it down. He set up a system of weather reporting using the telegraph so that people in the western part of Italy would tell people in the eastern part of Italy, hey, a storm is coming. He worked out for the Holy See, which is still an independent country then, the area around Rome, how to, cure disease by having better drainage in cities. He worked out standards for reinforcing buildings. He founded the first magnetic observatory. He invented a thing called the Secchi disc. If you're interested in how clear water is, basically it's a white disc with lines painted on it. You drop it in the water and you see how low you have to go before you can't see the white lines anymore. He invented that in one afternoon. He surveyed the Appian Way and set up the prime meridian that went through Rome. He played a key role in the metric system, which is what we're going to go back to. But most of all, he had a phenomenal effect on astronomy. And there's 3 books in the last couple of years that have come out. The first was in Italian. The second is a biography, which is written in English, Decoding the Stars, won the American Astronomical Society Historical Division Award for Best Historical Book last year. And then finally, this book on Angelo Secchi in 19th Century Science, which just came out less than a year ago, and I'm one of the editors of it. So I can go on about Secchi for hours. He was born in northern Italy, 1818, joined the Jesuits when he's 15 years old, teaching physics, in Loreto, the place that's famous for the house that flew there. He went to the Roman college to study theology. He's ordained in 1847, 29 years old. Fine. 1848, all hell breaks loose in Italy. Garibaldi's army marches into Rome. The Pope has to flee and goes off to Naples. All the Jesuits are expelled by the new Roman Republic. And so Angelo Secchi winds up fleeing to Stonyhurst. And that's where he learns astronomy. And he learns how to use the telescope up in Stonyhurst. The next year, he's invited to go to Georgetown University. So that's where he learns meteorology. That's where he learns the ideas of weather forecasting and having, wide-ranging. Finally, in 1850, the French army marches into Rome, kicks Garibaldi's army out, sets up the area, not just Rome, but the area, a few tens of kilometers or outside Rome. Secchi is invited back, and he's now 32 years old, and he's asked to take over as the director of the Roman College Observatory, teaching astronomy. Astronomy was one of those things that they taught since the Middle Ages in universities, because what they really thought of it was cosmology. How does the universe work? Secchi wants to build a telescope. They've given him this marvelous long, tall tower, but the tall tower shakes in the wind. Right next to the Roman college is a church called the Church of St. Ignatius that was designed to have a big dome, but they ran out of money. They never built the dome. And Secchi says, there are 4 pillars holding up the dome that's not there. I'm going to put a telescope dome on those pillars. He has a beautiful 10-inch refractor made in Germany on one of the pillars. He's got a transit telescope on another pillar. And from here, he starts doing astronomy, not the way that other astronomers did it. Because up to that point, astronomy was the measurement of the positions of stars. But he's fascinated. This is that German telescope I was telling you about. Beautiful telescope. That's a photograph from 1904, and you can still see the dome and the telescope. At this point, it's been long since been confiscated by the Italian government. And you can see on the roof of that church to this day, the base that the telescope sat on and the dome that used to hold the transit telescope. That's the view looking I think that's looking to the south. And if you look to the west, you can see that's the Pantheon right there. And beyond it, you can see the Dome of St. Peter's. So you're nice, high above the rest of the city. You've got a glorious horizon. It's the 1860s, so you don't have city lights really making things terrible. It's a fabulous place to do astronomy. Some of the astronomy he does is to go and observe solar eclipses. He observes one in Spain in 1860 where he takes a photograph of the eclipse, and then he compares the solar corona in his photograph with the solar corona taken by other people elsewhere, and they're seeing the same corona. And this means that the corona you're seeing is not something in the atmosphere like Galileo thought that comets were, but it's something actually at the sun itself. He has telescopes that are looking at the surface of the sun. On the left are his drawings, on the right is a modern Swedish image, and you can see his drawings are pretty darn good. And he actually, remember I said he was interested in magnetic measurements. He made a connection between the magnetic field on the Earth and solar activity. This connection is still measured today by a pair of NASA spacecraft, the stereo spacecraft, that have an instrument package called the Sun-Earth Connection Coronal and Heliospheric Investigation Package, which, as you can see, spells out his name. So, I mean, there is fame when you get a NASA acronym. They're never going to do that for Consolmagno, I know, too many letters. So, all of that would make him a phenomenal scientist, but that's not what he's really noted for. As I was saying, Astronomers in the 19th century argued what astronomy must do is determine the motions of the heavenly bodies. Everything else is not of astronomical interest. Bessel says that. The French philosopher Comte writes, every research in relation to the stars not reducible to simple visual observations is barred to us. We could never study by any means the chemical composition or the mineral structure of things in space. Our positive knowledge concerning the stars is necessarily restricted to just their geometric and mechanical phenomenon because it's impossible to undertake these other kinds of research. He's arguing there are kinds of facts that we know must exist, but we know we'll never know them. And then Secchi comes along and he puts a prism in front of that 9-inch lens, and every star becomes a rainbow. And then he draws and paints the colors and sees the lines where colors are absorbed in the gases around the stars. Fraunhofer had done this for the sun. One or two people had done it for Sirius. Secchi does it for 5,000 stars. And he sees that they come in a limited number of different classes, some with lots of lines, some with not so many lines, some where the lines are completely different because they're lines that he recognizes are due to the absorption of carbon. He calls them carbon stars, and he sees that they tend to be very, very red stars. He has changed the nature of astronomy from astrometry, measuring where the stars are, to astrophysics, asking what are stars. This is the basis that eventually goes into what became the Hertzsprung-Russell diagram, which is the fundamental starting point in all analysis of stellar populations and eventually stellar evolution. It all begins with Angelo Secchi. Why is it you've never heard of him? Because people in England were doing it at the same time. Norman Lockyer, who was the editor of The Founder of Nature, didn't like Secchi, among other things. He was a Catholic priest. And so he never allowed any of Secchi's books to be translated into English. But he was well known in the continent. He's well known in France and Germany. The other thing that Secchi does is he writes, which is dear to my heart as a planetary scientist, the first summary of planetary science, the physics of the solar system, with images of Mars. And he's looked, this is not from the book, this is actually from the Astronomischen Nachrichten of about 1858. And he is seeing markings on Mars, which are real markings, which he says in this book written in Italian, that they're come canali, like channels. Of course, as he uses that nasty word canali. The things that Secchi is seeing are real. You can see them with your own telescope. The canals of a generation later, those are optical illusions. But again, he's asking not where are the planets, how can I work out their orbits to another decimal point, but what are the planets? What's going on in their surface? He actually looks at spectra of Uranus and Neptune and sees lines saying that there's carbon and methane in those planetary atmospheres as well. 1870, Germany invades France. The French withdraw the army that they had in Paris to protect, in Rome to protect Paris. Garibaldi marches into Rome. Rome is occupied. The government of Rome, having been fighting the papacy over who owns Rome for the last 40 years, doesn't like the papacy. They're very anti-clerical. Secchi has to give up his observatory, so he thinks. But he is so well known that the Italian government and astronomers who work for the government convinced them to allow him to continue his work, even though the territory where the telescope is not connected to the Vatican. It's about a couple of miles to the east of Rome. In 1878, he dies. As soon as he dies, the Italians can't confiscate the observatory. In the early 20th century, they take the telescope and move it to another one of their observatories. And sadly, his beautiful 10-inch telescope is lost in a fire in the 1950s. You may know the name Schiaparelli, who is one of the great Italian astronomers of a generation later. In Schiaparelli's notebook, he writes on the death, while I'm making these observations at 7:15 p.m. Rome time, Father Secchi has died. Thus has Italy been deprived of its principal and most distinguished astronomer. So you have in Secchi someone whose reputation throughout Europe as an astronomer is first rate. But wait, there's more. Remember that machine I mentioned that records the weather? Secchi demonstrated that machine at the Universal Exposition in Paris in 1867. He wins the gold medal, he wins the Legion of Honor. Somebody, or a Frenchman writing at the time, says, if it weren't for that, the Papal States would have been really, not looking very good, because there's not a whole lot else going on in the Papal States. The biography I mentioned says, the awarding of this prize to a Jesuit undeniably was a jab at the anti-clerical supporters party who had been accusing the church of being anti-science. Interesting. Secchi's reputation is such that year, the French decide to have a new convention on redefining the meter, to define it more precisely. Every nation in Europe is invited to send a representative. The Holy See is still a nation because this is before 1870. 1870, before Garibaldi marches in, they form what's called the Committee of 1870, and then the fall of Rome happens. The Committee of 1870, working on various reforms of the meter, expressed the wish 2 years later that in spite of the changed conditions of the Holy See, the commission would not be deprived of the personal contribution of Father Secchi. But the Italian minister doesn't want to recognize the Vatican as an independent country. Remember, they've conquered all of Rome. They've stopped short of actually taking over the Vatican, and the Pope has declared himself a prisoner of the Vatican. The Italian minister sends a telegram to the French foreign minister. Dr. Secchi was sent here to take part in the work of the commission. He was received as a representative of the Holy See. Please make known to me if there's a place to ask for an explanation, or a place where we can express our reservations. How dare you allow him to be there representing a country that doesn't exist anymore? The Italian delegates, the scientists, try to tell their own government, don't do this. Any comments would produce a bad impression on the commission and the rest of the learned world. Nonetheless, the Italian government insists the king cannot let pass in silence this designation of a state that no longer exists. The Italian scientists are ordered by their government to protest, to refuse to take part in any decision if Secchi is allowed in. They let Secchi go anyway as the representative of the Holy See. The Italians abstain, and at that point, the Italians are kicked out of the meetings if they won't participate, because the rest of the group needs Secchi and Secchi's expertise. Secchi goes home, he meets the Pope. The Pope raises his hand when he walks in and he says, I vote for Father Secchi. The Vatican realizes that having a nationally and internationally recognized scientist is a way for the government itself to be recognized as an independent nation. Meanwhile, the Italian government is trying to raise this theory that all the church has always been anti-science, and that's when they raised this statute of Giordano Bruni, to the century predicted by him, the modern 19th century. And that's where the fire, so, nobody should have been burned at the stake. But if you read what Bruno was saying, Bruno was not a scientist. He's not somebody that I would want to have as a hero of mine. He was a crackpot. In America, a book by Andrew Dixon White is explaining the eternal warfare between science and religion. really what bothers him is that America is being flooded by immigrants from Southern Europe with vowels at the end of their name, like Consolmagno, like my great-grandfather. And he wants to keep people like me out because he believes in eugenics. He thinks that people from Southern Europe are inferior human beings. This is, and when the church objects to this point of view, they say, oh, but the church doesn't know modern science, which he thinks is eugenics. How is the church going to oppose this? Well, Leo XIII had a celebration for the Jubilee of his ordination. He invites scientists around Italy to show off scientific equipment. These are some drawings. That fellow in the red circle, that's actually a bust of Secchi. The guy who organizes it was a student of Secchi's, a fellow named Denza. And Denza goes to the Pope and says, you know what you can do? Organize a national observatory living off the good reputation that Secchi gave. This will show the world that we are a nation and also show the world that we're literally supporting science. So that's what Pope Leo does. Incidentally, that's Pope Leo's coat of arms. The family coat of arms happened to have a comet in it, which is kind of cool. Telescopes are built on the walls of the Vatican itself, including on top of the Tower of the Winds. And the Vatican is invited to take part in the first big international program to photograph the entire sky, the Carte du Ciel, which was organized in France, and the French loved accepting the Holy See as a nation because they didn't like the Italians. The Vatican is invited to photograph one section of the sky. The Italian National Observatory is invited to photograph a different section of the sky. Internationally, the Vatican is recognized as a nation different from Italy. So with this telescope, a section of the sky is photographed at plate by plate by plate, and then the bright stars are mapped on that plate by a group of computers, which of course in those days were women, Sisters of the Child Mary, making measurements of more than 500,000 stars. This was the astronomy going on at the turn of the century into the 19-teens. This was astronomy done by the Vatican Observatory. In the 1930s, finally, Italy and the Vatican sign an agreement. Italy recognizes the Vatican as an independent state, gives them back the Pope's summer home in Castel Gandolfo. The Pope gives this to the astronomers, and the astronomers bring in a group of young Jesuits from Germany, mostly, to build a spectral laboratory. This was a laboratory where they take pure metals, vaporize the metals, and then measure the spectra of each pure metal. In the 1980s, the light pollution, even in Castel Gandolfo, got too bright. And so a new telescope was built in a dark sky site in southern Arizona. And basically, the Vatican Observatory now has a group of scientists in Arizona, headquartered in Tucson at the University of Arizona, working on this telescope, which was the first spin-cast mirror telescope, and I could go on for hours about that. But I'm beginning to run out of time. So I will simply mention that to this day, the Vatican Observatory is a member as one of the nations participating in the International Astronomical Union. In 2006, when the discussion of Pluto came up, we've got an American, Rick Binzel, on the left, an Englishwoman, Jocelyn Bell Burnell, on the right, holding a little Pluto in her arms. But the fellow who wrote the document defining a planet and defining a dwarf planet is the fellow in the middle, an Englishman who went to Stonyhurst, who is a Jesuit priest, Christopher Corbally, a member of the Vatican Observatory and a representative of the Vatican City State to the IAU. We've got a dozen researchers now coming from 6 nations, 4 continents, doing everything from stellar clusters, stellar evolution, meteorites and asteroids, galaxy evolution, extrasolar planets, quantum gravity and string theory, spectrophotometry, celestial dynamics, more meteorites, philosophy of science, quasars. Each of us has a PhD from someplace in the world, like you've heard mine was from Arizona. Each of us has a group of collaborators in our own field, and we've got programs that we continue to work on, both in Castle Gandolfo, which is where I am now, and in Tucson. We've even had this, this former chemist. He had a background in chemistry before he got a new job. And he brought his own white lab coat, which I thought was pretty nice of him when he came to visit our lab. That's the kind of work that we do today. So thanks for hearing my stories, hearing a little bit of the history of how we got to be the way we are. And from here, I'll stop sharing and happily take any questions you've got.
Well, that was superb, absolutely educational, but at the same time entertaining. Thank you so much. I know you're a very busy person, and I'm very grateful for the time you've given us to give a bit of the history and the background of things. Some of that I never knew, and it's intriguing that Seki was in this country, just not too far away from me in Stonyhurst. So I need to find out about more of the stay here.
I'm not sure. I don't know
I've
the
just
exact
had a look
dates of
on
Stephen.
chat, and
Okay, I'm sorry. I was going to mention. I don't know if he overlapped with Stephen Perry at Stonyhurst. I'd have to look up the exact dates.
Okay. I can't remember myself now. It might be the 1860s. Would that be right? It was the time you said in exile anyway. So
yeah.
If you have a question for Brother Guy, you can either indicate by using the facility that Zoom provides, or you can do this gesture and I'll try and get to you. So does anyone have a question for Brother Guy, please?
I see one in the chat.
There's one in the chat at the moment, yes.
Right, from Martin Phillips, asking about Robert Spitzer. I've never actually met him, oddly enough. I'm familiar with his work. I can argue with him. I sometimes fear that he goes a little bit too far in trying to say that, science proves the existence of God. I don't think you can do that. Because if you could, anything that could be proved by science would be subservient to science. That wouldn't be God to me. Besides, science doesn't actually prove things. Science explains, tries to explain, but every time you explain something, if you do it right, you're raising more questions than answers. And which just means that, there's always a reason for me to go back and ask for more money to do more research. But on the other hand, he does do a great job, especially with, I think, a certain, subsection of the church, explaining to them that science is not your enemy. And I think 130 years ago, when the church first came up with an observatory, even up to 30 or 40 years ago, there was still a lot of trying to tell the scientists, no, we're not out there to usurp you. I found most scientists today don't do that. The people who still think there's a war between science and religion tend to be the people who don't know science or much about religion. They're the people in the pews. And so I'm a missionary of science to the people in the pews more than the other way around.
It's not a question, but Barry Williams has said that Seki gave a talk to the BAA meeting in Norwich in 1868. Sorry, British Association of Sciences, Norwich, on stellar spectroscopy. And it was reported that it was well received.
Yeah, well, he was very polite. He never, well, except with the Italians, he could be very cutting when he was dealing with his fellow Italians. But when he was overseas, he was always very polite. Spectroscopy was exceedingly controversial in those days. So the fact that they would listen to him talk about it. And it's not that the results were controversial, it was the fact that you're using valuable telescope time for this to answer questions that nobody's been asking. Why are you doing this? which I think you can hear, astronomers to this day, echoes of that still.
Could I ask a question, Gerard?
Yes, John,
Well,
go ahead, please.
I thought that was a fantastic talk, and I've got lots of questions. But the one that occurred to me, I'm a member of the Norman Lockyer Astronomical Society, who, as you know, is a very eminent Victorian scientist. I'm interested to know why Lockyer didn't like. Was it a personal reaction to him, or was it his ideas and thoughts, or the fact that he was a Catholic priest? I mean, I'm interested in your views on that.
It could be all of the above.
Mm.
One of the complaints about Secchi was, of course, he was in a hot field when lots of people were doing things at the same time. And the issue was he stealing ideas from other people, which is one of the things he was accused of. And that was the sort of thing that Jesuits were often accused of in Victorian England, of being deceitful. It just, Catholics in general. You remember that's exactly the time of the controversy with Cardinal Newman and the Apologia per Vita, apology for his life, Vita Sua, Apologia per Vita Sua, famous book where again he had been accused of stealing ideas. I'm reminded of once I saw an idea of mine cited by a crackpot, and I thought, hey, he stole that guy's a crackpot, and he got all of his ideas from me. Wait a minute, how can you do both? But I think it was basically a jealousy of priority, and those jealousies have always been a part of science. It was a part of science with Galileo.
Yeah,
it's a part of science today.
Do you know if they ever met? Did they meet each other at all?
I've no idea. I don't know that they ever actually personally met. I do know that when Secchi's book on the sun, which was probably his most famous book, came out, it was written in French and translated into German. And Lockyer was instrumental in seeing that it was not translated into English.
No,
and he gave a very bad review of it in Nature.
Right. Okay. Thank you.
Sorry, there's a correction on chat. Jocelyn Bell Brunel is Irish, not English.
Quite right, quite right. Oh, my apologies. And actually, I've been on a panel with her, and I'd heard that, so I'm very embarrassed. Oh, quite right. Incidentally, my mother was Patricia Clare Duffy, so I've got a bit of Irish in me too.
Any questions from anybody? Okay.
David's
David.
Yeah.
David's got his hand up. David, over to you, please.
That was a really interesting talk, Brother Guy. Thank you very much for that. But one question I had was, is the Vatican Observatory exclusively staffed by Jesuits? And also, are women involved, or do you anticipate that at some stage women on an equal footing with men will be involved? I noticed that all the thumbnail pictures of the staff that you showed were all men.
Right. The way it works is that the Vatican Observatory was handed over to the Jesuit order to find people to staff it. And that happened in the 1930s. And the Jesuit order is an all-male order. One of the people in those pictures is actually a diocesan priest, but the new rules specifically say that members of the Vatican Observatory have to be Jesuits. And there's a practical reason for this. We all live together in the same community, sharing expenses, essentially. Do you remember the old phrase they used to say back in the 80s when they're talking about yuppies? And there was a phrase called DINK, dual income, no kids. So you'd have a couple who decided not to have kids, and they're in some high-tech field and making lots of money. Well, we're 12 incomes, no kids. The actual salaries we get from the Vatican are pretty small. No normal person could afford to live on the salaries that we get. But when you combine them all together, living in a house that the Vatican owns, not having to pay taxes on that sort of thing, then in fact, not only can we live together and have computers and things, we actually donate the surplus every year to the observatory to keep it running. But you're right. This is a problem where there's no women. There's no lay people. There's no place for other people to be involved. About 30 years ago, Father George Coyne was a director then, invented a new branch called adjunct scholars. And these are scholars who are also very good Catholics, approved by the Vatican. We have to submit them to the Vatican to say, yes, they can represent us. But they're lay people. Several of them are women. The woman who wrote the book with me on, or edited the book with me on Secchi, Ileana Kenichi, she's an adjunct member of the Vatican Observatory. We have now an American chemist, Michelle Francildone, and an Italian woman working in dark matter, Maria Elena Monzani. And these are just, these are the three of the dozen or so adjunct scholars who are also part of us. And we're working to expand the number of women. Plus, we've got summer schools and colleagues and people who will spend sabbaticals with us. So the observatory is no longer a little group of people all working by themselves on a little mountaintop isolated from the rest of the world. We are now people who are all collaborating with men and women from around the world and who have access to our facilities and can use our telescopes along with us.
Benny Taylor has a question he would like to ask.
Sure.
Hi, thank you. And that was a brilliant presentation. So here's a question related to the kind of the God question. Okay. And I'm not a religious person asking this question, just put it out there. But I'm also not blind either. In Josephus, he speaks about the source of Abraham's determination of the one God. And Josephus speaks about the source, and it seems like a quote within Josephus itself. He says that God must be, fundamentally, there must be a God, because when he looks at this, when he looks at the movements of the animals and the plants, they appear to be orchestrated by the sun, the moon, and the stars, which is biological clocks. I mean, it's circadian rhythms. That's basic in today's world, and also known by indigenous. So he said, because there is this orchestration, and that orchestration helps us as human beings, therefore, there is a God that is there for us. There's a force. So the sun, moon, the stars don't do this all by themselves for their own purposes, because he recognized they're all different. But they do it for us. Therefore, there is a blessing from a God that is given to us. So is the question of God within astronomy, because this is an astronomical question, according to Josephus and how he writes of Abraham. Is the question of God really astronomical versus spiritual?
I would put it a different way. What he's doing is what we now recognize is the God of the gaps. Here's something I don't understand, therefore I invoke that there must be a God in order to make it happen. And then a century or two later, somebody comes along with a natural explanation for it. Newton was guilty of this. Newton couldn't figure out how the planets could be stable and invoked the hand of God to keep the planets stable from perturbing each other. Then Laplace comes up with better math and says, you don't need the hand of God. If your idea of God is one more force alongside all the other forces to make nature work right, then that God is basically no different from Zeus. It's just a pagan God.
Okay.
And that's not the God that I want to believe in.
Well,
Stephen Hawking had this marvelous phrase. He said that, the Big Bang occurs because of a quantum fluctuation in the fabric of space-time. And we all know that bending space-time is what we call gravity. And so he says, because there is a thing called gravity, I don't need, the universe would create itself, and I don't need God to set it off. Again, he thinks that God is a force alongside other forces. Of course, he's not saying there's no God. He says, by his definition, God is the thing that started the universe. And then he says, gravity is the thing that started the universe. And that doesn't mean there's no God. It means that gravity is God. Which, if gravity is God, maybe that explains why Catholics celebrate Mass.
Okay.
Anyway, bad jokes aside.
James has got a
bad jokes aside.
James,
right. I think I've just lost. But my point is, It's philosophically the wrong way of looking at God. God
Okay.
is not the conclusion you come to at the end of a logical sequence. It's one of the assumptions you make at the beginning. It's one of your axioms.
Mm.
And therefore, if you choose as an axiom, no God, you can, try to make sense of the universe that way too.
Mm.
And both systems can work. You can't use that as a reason to believe or not believe. But in the way that they work, you can say which is more the ring of truth to me, the one that explains things that the other doesn't explain. I can give you excuses for why I like this system, but that's hardly the same thing as saying it's a mathematical rigorous proof, because it isn't.
Thank you.
Okay, thank you, Benny, for the question. I'm
There's
going to go
one-
to the last question for this evening
Yeah.
from James Dawson, who's masquerading as Nottingham Astronomical Society. And his question is, have you observed through an optical telescope with the Pope?
I have not myself personally done that. Others have. I'm told that there was an eclipse in 1999. I was up in Germany looking at rain on top of me, but the Pope was in Castel Gandolfo. It was during his summer visits. This would have been John Paul II, and he came out to the observatory and looked through one of the telescopes at a partial eclipse that they could see there. We have wonderful film you can find on YouTube of Pope Paul VI looking through the finder scope of a Schmidt telescope at the night of the moon landing. And there's one last example of this. You remember that picture I showed you of the Carte du Ciel telescope from about 1900, the guy's photographing the sky. The fellow doing the photography has got this long cassock on, it looks kind of peculiar. His name was Giuseppe Leis. He was one of the astronomers at the Vatican Observatory in 1900, 1910. He had a group of kids that he would teach astronomy to and let them come in and look through the telescope. One of the kids that he let in was a fellow Eugenio Pacelli, who became Pope Pius XII. Pius XII was a passionate amateur astronomer, loved looking through the telescopes, and used his family fortune to buy that Schmidt telescope that Paul VI used later on. So I've never done it, but others have.
Okay. Ladies and gentlemen, I'm going to bring the webinar to a close, and with a message to Brother Guy to say thank you so much again for giving up I know you're a very busy person, your precious time to speak to us this evening. So may I ask everybody to show their appreciation either by symbol or by physical means by giving their round of applause. Thank you very much indeed,
Thank
Brother
you.
Guy.
Thank you.
Thanks for having me.
Very interesting. Thank you.
And thanks for laughing at
can
my
I
jokes.
just-